Ayo, this is the video for Piecewise. So welcome. All right, and we're going to talk about piecewise functions today. So a piecewise function is a graph of only a piece of a function based on a given domain. So here's what I mean by that. With piecewise functions, we're not graphing the entire thing. So when we graph the line, just for example, y equals 3x plus 1, we know it goes infinitely direction. We start at 1, up 3. I'm just going to do a quick sketch real quick over 1. It goes infinitely both directions. That function does, okay? It goes forever to up and to the right and forever down and to the left, okay? So now with a piecewise function, we're only going to take a certain piece of that graph, and we're not going to, so it doesn't go on forever both ways based on what information we're told, okay? So here's an example of what a piecewise function might look like. You have y equals 3x plus 1 for when x is greater than 2. So we're given a specific domain right here, and we're told that if this graph, all I want the piece of this graph where x is greater than 2. Okay, so I want a piece of this graph, of this line, when x is greater than 2. Okay, so let's look at this exact function and talk about this. So hold on real fast. Okay, so if I have 2x plus 1 when x is greater than 2. So what I want to do is I'm going to graph this particular function right here. Okay, so first I'm just going to graph it like I normally would. So I'll start at my y-intercept, plus 1. And then I'll go up 2 over 1, up 2 over 1, up 2 over 1. Okay, I'm going to keep doing that. So here's that line. Okay, that's a pretty impressive straight line right there, just saying. Now, there's that line. What I want to do though is now it's for the piecewise though, for the piece of the function that I want to, it tells me just to graph it for when x is greater than 2. Okay, so here's my x-axis, here's my y-axis, and I'm looking when x is greater than 2. So let's find 2. Well, here's 1, here's 2. And I want to know, I want the piece of the graph when x is larger than 2. So if I go up here to my function from 2, I'm going straight up, this is when x is 2. Okay, when x is greater than 2, it would be everything to the right of 2, because that's when I have 3, 4. These are all values that are greater than 2. Okay, so that means for my graph, I want to go from when x is greater than 2. I want this piece and everything to the right of it. So all of this, because for all of this, x is greater than 2. X is 3 here, x is 4 here, x is 5 here. Anything below this, though, or to the left of it, is 1. This part is not greater than 2. So what I can do is I could actually erase this piece of my graph. Okay, could erase that piece. And I'm almost done already because that's showing me just the piece where x is greater than 2. Except for we have to determine whether or not we have an open or closed circle on 2. Okay, so again, if we go back to what we've learned before in the past in my previous videos, I used to have these faces. Okay, so when we had less than or equal to, greater than or equal to, less than or equal to, we would have a closed circle and a solid line. And then if I have no or equal to symbols, I have an open circle and a dashed line. Okay, so because it is greater than, and there is no or equal to symbol here, instead of having a closed circle on 2, I will have an open circle. What that means is that there is a hole in this graph, okay, at 2, because it wants to know what's greater than 2. So right now, at 2, I don't really care about what my function looks like at 2. I want to know greater than 2, but I got to start from 2. Okay, so I have an open circle here on 2, and my graph keeps continuing on. It's the same function as 2x plus 1. I just erase the left side of it at 2 because I want to know what the graph function looks like at x is greater than 2. So I'm taking a piece of the entire function. Okay, I'm erasing the piece that I don't want, and then I'm determining if I have an open or a closed circle. Okay, let's look at another one here. So here I have the function of a line that I need to graph, negative 1/3 x plus 1. Okay, and then I have my piece of it that I want to graph. I want to worry about when y is less than or equal to negative 1. Okay, so I'm going to graph this one in a different color here. Okay, so first we just start off by graphing our function like normal. I start at my y-intercept, which is 1. This is a negative slope, so I'm going to go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Down 1, 1, 2, 3. Down 1, 1, 2, 3. Okay, perfect. So Not quite as straight of a line, but it's not bad. So there's my graph of this particular function. Okay. So now I'm only worried, now I got to figure out what the domain it's asking me for. It's asking me for y has to be less than or equal to -1. Well, this is my y-axis, and this is my y-axis at -1, right here. Okay, so here's where my point is there. It's telling me it only wants to know, it only cares about the values that are less than -1. Okay, so if this is -1, the values that are less than are going to keep going down because this would be -2. -2 is less than -1. So what I would do is I only want the values on my function that are below -1, that are underneath it, because that would be less than. I do not want anything above -1. Okay, it's almost like I can draw a line here at -1 and say anything above this line is not what I want, is not a part of my function. So that is what I can erase. I can erase everything up to -1 on the top of it. Okay? And then I also get to look at, do I have an open circle or do I have a closed circle? Okay, at -1. And because I have this or equal to symbol underneath, I do have a closed circle, so my piecewise function is done. Okay, let me make it look a little bit nicer here. Okay, my piecewise function is done. There's my graph where y is less than or equal to -1 because I'm only graphing below. I'm only showing all the values of this particular function that are less than -1. Okay, it does go on forever this way, right? Because this is going to continue to going on further negative, and it's going to continue to be less than -1. Let's look at just one more example just so you guys get the hang of it. So try this one on your own and then watch, just come back and watch and make sure that you did it correctly. In the meantime, while you guys are waiting, let's go ahead and give you guys a good math joke here. So why can't the number 4 get into the nightclub? Why can't the number 4 get into the nightclub? Because he is too square. All right, that was a good one. Okay, so here's my function. Y equals 2x minus 4 for x is less than 3. So I have my function 2x minus 4. I'm just going to graph that first. 1, 2, 3, 4. Okay, and then up 2 over 1, up 2 over 1, up 2 over 1. Okay, so some of you may notice right now I'm already at 3. Okay, so I can probably, I know my point is going to be here because this is when x is 3. So I figured out my value when x is 3 here. Okay, so there's the point that I need to start with because that's what my value, that's what my graph is asking me about, when x is less than 3. Okay, and because x is less than 3, I could keep going. I can go up 2 over 1. But this is probably going to be the part of my graph that I erase because x is less than 3. Okay, I'm sorry, this is probably going to be the value of my graph that I erase because x is less than 3 and all these values are greater than 3. But that's okay. So you'll be able to catch that eventually, where you don't have to actually graph so much of the line and then erase it. Notice how my line missed every single point. Don't do that, please. Okay, but eventually you'll be able to notice right away when you're at x is 3 that you don't need to keep going because it's supposed to be less than, but that's okay. We can erase, it's not a big deal. So here's my function, just 2x minus 4. All right, and then I got to look, x is less than 3, so here's x is 3, and then because I know it's less than, I only want the piece of my graph that is less than 3, so that's everything to the left here. So that means everything to the right I don't need, so all the greater than values are gone. Okay. And then I got to determine if I have an open or closed circle. Because there's no or equal to symbol, it is an open circle on 3. And then there's my graph going forever down and to the left. Okay, so again, you guys, a piecewise function is just a graph. We graph our function like normal, but then we're erasing part of it because we're only looking at one piece of it. Okay, and we're looking at the piece of it that it's asking us to look at. I'm looking at the piece for this particular graph. I'm looking at the piece when x is less than 3. So this line this line, if I didn't have a piecewise function with it, would be going on forever in both directions. But because I'm only looking at the piece of x is less than 3, I erase everything that's not less than 3. So I erase everything that's greater than 3. And then I have my function, my piecewise function of 2x minus 4 for x is less than 3. Okay? So good luck. Let me know if you guys have any questions, and thanks for watching.